We found a nice repo from Facebook Research. I had submitted, there was an issue raised to add support for the LLaVA model. And I didn't get a response from the initial author of this issue. So I'm actually just going to implement it myself. So I'm actually quite excited to implement this. I've never worked with multimodal, a multimodal model before. So this will actually be a lot of fun. Go to hold on. I want to go to, oh, there's even code as well. So this is nice. We'll have a lot to, we have a lot to pull from when implementing and adding support for this. It seems like if we go back here, it seems like just adding the model to the model's directory is a good first start. We have clip visual encoders. And then the bulk of the work for the model should be to add the LLM. A couple pointers to help with that. The decoder layer, root mean square norm, and then rotary positional embeddings, which is still a PR. I don't know if this is merged. Doesn't seem like it has been merged. It's still open. So we can probably set that as like a flag to change it or something like that. We'll see. All right. So, without further ado, 1 second here. Let me SSH in to my server real quick. All right. Save. Go to multimodal. All right, models. So we have all these video GPT, masked autoencoder modules, encoders. What's the okay? Fusions, attention, layers. Okay, losses. That's okay. Masking, optimizers. All right. Let's first make a branch here. Or actually, hold on. Conda create modal. Does this say what? 3.7, 3.8, 3.9. Okay. Actually, I don't want to. Bruh. Conda create. Torch multimodal Python equals. So anything greater than or equal to 3.8, I'll use 3.9. Python. Okay. Yes. And then conda install. I do want CUDA, PyTorch, Torch Vision, Torch Audio, PyTorch. Oh wait, but I think it's busted. Yeah, I forgot. Why is there? Damn, do I need to fix this first? All right, let's go. Build to initial VML. Driver library mismatch. No way, it's just a reboot. Damn, I gotta reboot my server, bro. Alright. Alright, we'll wait. Yeah, I forgot that my driver was all weird. So let's just give it 1 sec. And obviously I'm on a VPN, so good luck trying to get into this without the configuration. Alright, what's good? I have 1 viewer. What's good, 1 viewer? Was Bracken 1 viewer? Nothing? Alright, I'll just talk to myself. Dono wall, bro. I absolutely hate programming on Windows. That's why I have a server. I have a dedicated server specifically for development. It's an Ubuntu server. Has GPUs, has a bunch of nice stuff. It's so worth it. I literally just use this mainly for gaming and obviously streaming now. But in terms of actual development, you will never catch me doing actual development on a Windows operating system. Never, 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 never. There was a part of me that wanted to originally dual boot, and actually I can dual boot. I do have a small SSD that has Ubuntu, but the resolution got all messed up, and I don't know what I did, because it was just one day it was working fine. I was able to get, I have a 1440p monitor here, and I was able to, you know, have full resolution, full frame rate, everything. And then I boot one time, and then it just gets busted. I don't know what happened, so I just stopped. So yeah, there's that. I have a 3090, which is nice. Founders Edition. Shout out. Come on, bro. Reboot slower. No, please take your time. All right. Let's see. I'm interested in lava. We can start looking at lava while we wait. Because I haven't gone through the paper fully. Oh. What is this? HTML? So we have a vision encoder, and then a linear projection, and then the language model, And then this encoded and projected representation, is fed jointly into the language model to get a language response. Now, for training, we might have to consider. I don't know if we have to consider their training paradigm for the multimodal training, because this is used for training at scale. Maybe we could just start with support. I think let's not be too. Let's not make things too complicated and ditch this training paradigm for now and just focus on implementing the model itself. Are you up? Come on, bro. Okay. Bro, Eminem, shut up. Holy. I guess, dude. I guess we'll just start here. This specifically is what we're going to be focused on. Now, obviously, their figure is very nice and tidy, and at its core, it is rather simple. You take the image, take the language, encode and project. What's Z of V again? The visual features, and then HV is we apply a trainable projection matrix to convert Z of V into. Oh, I see. We got to follow the arrows. Okay, I see. So the projection is only for the image then. Whereas X of Q, which is the query, I assume, is just encoded. Perhaps. I think it's just directly encoded. And then we get the. Oh, so then H of V is W dot ZV. Okay. With ZV being G, where I assume G is the encoder. Yes, it is. It is provided by the visual features, the grid features, before and after the last transformer layer are considered. Huh? Okay. We consider a simple linear layer to connect image features to the word embedding space. Specifically, we apply the matrix. Okay, so we use clip, encode the image, and then project it. And then we get the. Why H? Like hidden? Like is the hidden, we're in the hidden state? It's a hidden state, hidden space? I don't know. One thing when I read papers is that I'm always trying to understand obviously what they're talking about specifically. But honestly, one of the most important things to know when you are reading a paper is to ask yourself, why did they name this variable what they named it? Why are they using this terminology specifically? That is so important, because if you can make that connection, then it's no longer just variables and math. It's very much a simplified language of what they're doing. And that's really tough. If things are named poorly, you're done. Good luck. It's Jover. GG. But if the researchers or the authors of the paper are able to name things rather straightforward, or they're following a paradigm that is kind of established in a domain, in a niche, then it's not too bad. It really isn't that bad. Please work, bro. All right, let's go. Please work. Please work. Please work. Please work. Ooh. All right, we got our GPUs. All right, yeah. What was I doing? Oh, I was installing the repo, dude. All right, dude. All right. NVIDIA. What is my? All right. So conda install PyTorch, Torch Vision, Torch Audio, PyTorch CUDA equals 12.2. C PyTorch nightly. C NVIDIA. Why? You'll just on. Wait. Oh, do I need to? Yeah, PyTorch CUDA. That's what I did. 12 point. I have 12.2. Oh wait, I'm in base. Oh, thank God that failed actually. Conda activate. Torch multi. Why? Oh, PyTorch nightly? Sick, dude. Absolutely sick, dude. PyTorch. PyTorch. Please work. If I fail installing it, it's over. PyTorch CUDA 12.2. Can I just use 12.1? Even though I have 12.2? Hopefully. I mean, if I have 12.2 and then PyTorch CUDA is 12.1, I don't think that'll be a huge issue. That shouldn't be an issue. Yeah, okay. Let's go, dude. We're installing. How did they implement Clip? Image transform. And then torch stack. Okay. Oh, that's how you transform. Take your time, bro. So I'm not gonna lie to you when I say that this is very much outside of my comfort zone. I've never actively, I've actually never contributed to open source, and so I really am just kind of jumping in the deep end here. But that's just kind of how I've always learned. And so, you know, if I fuck up, I fuck up. That's fine. But you know, I've never actively worked on a multimodal neural network, although I'm pretty comfortable with neural networks. And I've never really contributed to open source, although I am comfortable with coding. So I think this is it's natural. It's a very natural next step, and this is how you kind of have to be, I feel like, to grow as a researcher, as a programmer, whatever it is. You have to constantly throw yourself in the deep end. This is kind of the only way that I've ever learned personally. And do take your time, please. So much to install, bro. So what's in clip? Image encoder, the model, and then the text encoder. And then what's in there? Init? Nothing. Okay. Okay. In clip, init. Okay. So models. What I'll do is I'll create a new directory. Well, let's finish this first, and then I actually have to create a new branch. Okay, great. Get status. Get branch LLaVA. Check out LLaVA. Models, and then let's create a new file here. All right. Let's go here to this init. I'll call this model.py, even though we won't really have anything right now. And then let's go back to the network here. So for the input image, we consider the pre-trained clip visual encoder. Well, let me see clip or LLaVA, the LLaVA model here. Model. Let's see the multimodal. So they have the clip, and then what's the builder? Okay. Clip encoder. Model, language model. And then they have different ones. Okay, cool. So it supports different ones. What's in the LLaVA architecture? Here we go. You have vision tower. Initialize vision modules, unpad image, and then LLaVA meta for causal LM. Encode images, prepare inputs. Modal encoder and projector. What's the builder here? Identity map, simple res block, linear pre-norm, and the projection back onto. Okay, so this is a residual. Okay. Let's go to so many tabs open. The projection W. The projection W.zv, the grid features before and after the last transformer layer. We consider a simple linear layer. All right. Okay. But is it a simple linear? Or is it linear? Jello linear? Ideally, if I implement the model correctly, I should be able to just bring the checkpoints and copy them over to the architecture that I built. Projector weights. So let's start. I mean, honestly, I'll just start with a skeleton. Bro, where's my extensions? Yeah, why isn't it? Oh, because NN. Okay. Let's see how they integrate this. And they do it as an NN module. Okay, great. Image encoder, text encoder. Okay. So we will have I don't want to deviate from how they do this too much. So image, text. You know, I do obviously want to follow we'll start with this. And then they have it to output, which I assume is a data class, the name tuple. Okay. And then all of these. I see. So image encoder. Text encoder. And then image to MM. What is LLaVA? I mean, it is Flava, but like, nah, I'm looking for something else. Google. Yeah, what's MM? Image text. Oh, multimodal encoder. Okay, so we don't need this then. And then what's image? We will need an image projection. All right. And then what we can do is then go data to embeddings. Okay. So then let's start with this. Happening. What? Go. Why though? Can I do it through? There's no remote branch. Would you like to publish this? Okay. Okay. So, okay. Oh, is it because? Oh, no, no, no. Okay. Check out main. Get branch. Okay, okay, I see. New folder. LLaVA. File. And then init. All right. Oh, I'm committing. I'm not adding. Oh my god. And let me. So now, okay, great. And then if I go to PRs, I will delete this. Go back to my profile. So all right, I'll just create the PR and delete it. Done. All right, cool. All right, let's go back to this. So we have, if we have the image encoder, and then the text encoder, and then the image projection. So ideally, self.image, let's say encode and project image, and then we will feed in the image here. Embeddings. And then this should just be the text encoder of text. And then, are they concatenated? Embeddings. And then pass through language model. And then return response. Okay. Encode and project image self. I guess this technically has to be optional. And then I guess this should return a tensor. And so if we do self.image image encoder of image image, I mean, I ideally we could just return image projection of the encoder. Ideally. Okay. And then we have a sequence of visual tokens HV. More sophisticated schemes to connect them can be considered, such as gated cross attention, Q former. We leave exploring more, just future work. But what do you guys do? I guess we have the code. Let's go to the code. So many issues. I mean, yeah. This is the multimodal project. That's done. Okay. Look at the model. This is the meta model. Oh, so there is a multimodal. Okay. This is ABC. Okay. So I guess we could theoretically we will say connect embedding. Joint. I'll call this joint representation. So what's Q-former? What do they call Q-former here? Extract visual features from the frozen image encoder. Fucked right. I guess this is the multimodal encoder. Let's go. Also, fix the settings. And then this should just be tensor. And then text embeddings should also be tensor. And this will also output a tensor. And then here, I'll call this, yeah, this is joint representation connection is not the best name, but connection equals joint. But it makes sense to me, and then if anyone makes comments in the PR review, then I'll change it then. Joint representation connection. But this, I mean, this could just be the multimodal. Here they have the multimodal encoder. So I may have to do something like this as well. And then, let's see. So what do we add? I'll just say continuing the skeleton. Okay.